Hi everyone, I'm Tiago Rodrigues. I'm an OutSystems architect, and this is the first of a series of videos that I'm going to make, mostly regarding OutSystems and GenAI and how we can use both of them to leverage processes, to leverage to solve any kind of problem we want to solve, right? That Gen AI nowadays can do a lot. So one thing important here is that nowadays we see a lot Gen AI and ChatGPT and agents. We heard all these buzzwords, and most of the times we are still likely to think of Gen AI a bit like a typical chatbot that we have in our website, and we can interact with it. And yeah, most of the times we do not like the interaction because it takes time. It requires us to to talk with the bot, and I really think that the future of AI will have something like that. So we'll have assistants, no doubt about it. But one huge part of the use cases that I do not see so much the market being focused in is how can we really use Gen AI inside processes, inside complex processes that need to be broken into the smaller, simple tasks, and inside of those simple tasks, where can we replace human actions with Gen AI? And so most of the videos I'm going to do are going to be focused on that, on how can we achieve more complex tasks breaking in smaller parts, and most of the times how can we leverage OutSystems. That is a very cool tool to prototype and to try to experiment the complex systems of Gen AI. Even, for example, if we go to multi-agent systems, we will go that on another video. But yeah, basically my videos will be focused more in how can we leverage OutSystems with Gen AI. Okay, so today what I want to focus is two characteristics that we hear a lot in everyone that tries to go inside AI world. That is fine tuning versus RAG, or basically data, any kind of data access. And I'm going to talk. I'm going to introduce a bit that topic because I think it's important to know the difference between RAG and fine tuning. I'm not going to deep dive a lot into the Gen AI part and the neural networks. I'm going to give here some resources, so if you guys want to learn a bit more about. But I'm going to explain a bit the difference, and I want also to focus on the part of the fine tuning because it's something that I think the market is not right now talking so much about it, but in the future, when we want the models or the agents to use in our business, when we want them to become more efficient and precise, most likely we will need fine tuning. Okay, so let's start. Okay, so starting with, and very quickly just talking about the models, right? The ChatGPT, all those Gen AI models, Anthropic, Cloud, those are different models, Gen AI models, and of course the inside are very complex. They have a lot of what it's called neural networks inside of it, and even interactions between them and calculations. But just for the purpose of this video, and I'm going to share this this resource here, but feel free to watch this video here in YouTube, where basically he shows, the author shows with physical knobs. He shows a bit what are neural networks. So you guys can see here that this is a very simple one, basically a 4x4 neural network, so he cannot do much with it. But if you see, whenever you heard about neural networks, imagine this being a sort of a network of nodes where each node has a value and they are tied together, so that when you give them a certain input based on the values that they have here, they let more or less value, or they activate or deactivate until they reach an output, right? So I will not detail this more, but I want you guys to know that these values, they are trained. So whenever you hear that a neural network is being trained, or the models are trained with the documents from Wikipedia or from the internet, you guys can imagine a process, a very slow process of giving a lot of information to these systems, and basically having a way for the system to fine tune, so to increase or decrease each one of these nodes until it reaches a satisfactory result, right? So the process of training is the process of changing these values. Okay, so it's an important thing to retain here is that when you have a trained model, for example GPT-4 or something like that, these values are fixed. They are already trained, they were already trained before, and they don't change. So all those values, all these weights remain the same. So this means that basically when you are training a module to do this, it's a bit like simulating our brain, right? We are learning, but most of the times we want the model to be able to fetch some information, to go to a database, to call functions, to produce certain results. And one of the ways that exists nowadays to fetch information is using RAG. So RAG is basically, I will not deep dive into it, but I will leave also this video, explains very well the difference between RAG and fine tuning, and they also explain a bit when we should use both scenarios. And an important thing to retain here is that RAG basically means that we are creating a very efficient index sideways of the model, and that index has a sort of a matrix that can very fast, and with good context, he can fetch documents that were stored, or data that exists on the database. So it has a sort of an index. So in a very raw comparison that we want to make here, and this article here of IBM shows very well that situation. When we are talking about using RAG to retrieve data, it is a bit like, if you want, imagine that you want to cook, to do some cooking. So the RAG is like you buying a cookbook with recipes, and basically whenever you want to to make a recipe, you open the book and you consult that information, right? You have the index, so you know the page where to find, and you can do this. So it takes time, but for the RAG systems, they are very fast doing this. So if you guys analyze this, I'm not learning in that moment. Before I open the book, I'm not learning anything about the recipe, so my brain stays the same. I'm not learning anything. Of course, that's because we are humans and we are constantly learning. The moment that I open the recipe and I start following a bit, some people might memorize it better and learn. Other people might simply forget it because they are reading from a book, so afterwards they can check again. And other people, they can even do a sort of a critical thinking process where they read the recipe and they say, oh, this is basically like that one, what happens if I do this and that. So they start this process of thinking. And yeah, in that case, in that situation we are learning. But let's assume here that for the models, for the RAG, they do not change anything. They simply have a very effective way of fetching data. Okay, so this is RAG. What about fine tune? So fine tune, and this is the keyword for today, fine tune is the process of retraining a model so that the model becomes more efficient and more precise for what he was trained for. So in this case, fine-tuning, picking exactly the same example, it's like you doing a cooking course. Okay, so in this case, what happens behind, and let's check here again, is that we are giving a new set of documentation and information to the model, and we are retraining again the model. So we are changing the weights of these knobs here so that the behavior of the model changes. So this means that after a fine-tuning process, the model will be a new model. It will not be the same as before. So this means that the model here is learning. He is not just accessing data, he is really learning new processes. And basically, this means that the model, after a training, he will target the questions and the answers, and he will give information more related to what he was retrained, right? So if you guys give a bunch of documentation, let's for example assume that you guys pick a book and you give him the full book and train him, after that process he will be more able to reply to questions, for example, about that book, about the story, or so on. One thing to consider is that when you guys are fine-tuning, you are changing the weights of the model, right? But exactly like us humans, for us to become really good at a certain topic, we must repeat. We must learn and use it and learn and process, reprocess. So we need time to become really good into something, right? And in here in the fine-tuning is the same thing. So the fine-tuning, no one should expect that we after retraining a model that he becomes already perfect in that situation, because it's a slow learning process, right? Exactly like us humans. So of course there are techniques to increase that, run more sets of training. You can do something that is the self-learning capability, so to have a way, for example, every night to retrain the model with the most recent data. So there are processes of doing that, and with time the model becomes better. But nevertheless, this is a very important thing to consider, and I believe that in the future, the more we will use smaller modules because they are cheaper, they are faster, and they are more economic in terms of energy consumption, we will need to fine-tune those smaller modules so that they become better at specific tasks. So we don't want them to be super models that can do everything and give you any information of the internet. We just want them to be a simple, small, humble module, but very good at a specific task. Okay, and in that situation, fine-tuning is a very good tool for this. So why am I talking about fine-tuning? First, because I think it's an important thing and there isn't a lot of conversations about it. But second, because I wanted to try, by curiosity, I wanted to try to train models and see the results of those trainings. So by going to Azure Foundry, I had this curiosity of by having here some deployment modules, what would be the difference if I train them with something, what would be the result. Okay, and in this case Microsoft also has here very cool tools, because we can do these fine tunings, and we will go through to this. We can do the fine tunings, and after that we can even perform evaluations where we run or basically Microsoft, the process behind, runs a set of evaluation questions, and he even produces a result. So for example, we can see here that we have these two evaluations. One of them was made on an original module, the other one was made on a module trained to become an OutSystems expertise. I will show it after, but you guys can see that after that the module lost a bit the fluency of talking so much in a fluent manner, but he became more precise in the questions regarding, for example, OutSystems. So this is an example. But how do we go here? And this is an important thing. When we are fine-tuning, we are basically giving the model a list of conversations that we had with him. It's a bit strange, because it means that the model can only train if we give him the format of user said this, you replied that, user said this, you replied that. But it's the way how it's done here in Azure OpenAI and also in OpenAI. But basically it means that whenever we want to give him something to train, we always need to use this format, JSON-L. So if you guys can see this JSON-L format, what it has, it's a list of JSONs with the typical format of conversations with the model. So you guys can see here that there is this listed message. The first, the user said this, who created the document, and the assistant or the model in this case replies saying this. So this is the file we need to use to train modules. And if you guys check this, we might have a problem here. And the problem is that basically almost no part of the internet in terms of documentation has this format. So if we want to train a module to become a super OutSystems mentor, or to become very good in specific systems, if you guys go to the internet to fetch information to train the model, the information, it's not like this. Most of the times the information are web pages, PDFs, documents, markdown documents, so it's not prepared for this. So because of that, I had then the idea of using OutSystems to create the Knowledge2JSON. So what is the Knowledge2JSON? The Knowledge2JSON is is an application that basically converts knowledge to the format that I showed you guys here. So let's take here an example. For example, this is a small one, OutSystems one doc. It was just to train with one. So you guys, let me just check. Yeah, that's the best one. So yeah, we have here this process we created, and basically we have two tabs here. The first tab is where we give the knowledge to the system for him to consider, and we have then the second tab with the list of questions and answers for the model, right? And we can here download the JSONL. So let's, for example, consider some more documentation here. We don't want just this. Let me go fetch OutSystems documentation. By the way, all OutSystems documentation exists in a Git repository, so if you guys want, you guys can easily fetch. So we have here some documentation, for example, here for the integration builder. So let me pick this data, and you guys can see here that we have these files. Okay, so in this case they are markdowns, but we can put JSONs, PDFs, documents, what we want, right? So in this case I've added this documents, and when I go here I can then start the process. And yeah, this was completed, but he will start again a new process, and we can see here that he goes into a process where he starts analyzing the documents, and he starts retrieving information about the documents per se. So he first goes into a process where he converts everything into a markdown so that it can be more easily processed by models, and then document by document he starts generating JSON questions, so to say. So if we go here, you guys can see that we already start having some questions here. What should I check first to start using Integration Builder? To start using Integration Builder, the first thing you should check is how Integration Builder works by referring to the relevant documentation. Yeah, some questions are better than others, but you guys can see here that he starts creating a library of questions, right? So he does this and performs this with all documentation until he considers that it finishes, and that's it. After that we have here a list. So basically what is happening here under the hood is that when I run a process, right, he checks if it is a markdown document. If it is a markdown document, perfect, we don't need to do anything about it. If not, this needs to be converted. So in this case I'm using Azure AI Document Intelligence, and I'm giving the PDFs, the images. He also can read images, he can retrieve context from images. And so we have here the convert to markdown text, and after converting the markdown text, he starts breaking the document in sections. So if we would simply give a full set of document to a GenAI model for him to add to create these questions, it would not be effective, because he would be limited by his short-term memory. So you guys can consider LLM models to have the context, that it's basically the history of conversation we have with them, and this context is a bit like our short-term memory, right? So imagine that someone goes to you guys with a document of 10 pages, and they say, hey, read this, memorize it, and then give us a set of questions and answers based on this 10 pages document. So it would be really difficult to do that. You would take a lot of time reading it and trying to memorize everything and so on. So in here, what I do is basically I break the document into paragraphs, and by paragraph I give the model and say, hey, here you have a paragraph, give me some questions and answers regarding this part. And so he does this with all the sections. For each section, he calls the module to generate the set of messages, and then the process is finished. And of course, we can then download the file that was generated. So going back here, okay, this one is already completed. So we have in total, from these 7 documents, we had a total of 384 questions. So if we go here and download the JSON, we can see now that this is already in the format desired to fine-tune the model. So right now, with this document, we can go here to the module and we can fine-tune. We can select the module that we want to fine-tune. Then this is basically a similar situation with the rest. I will not go through this because it was not the focus in my video, but by having this process here, it becomes way easier to convert documentation into a format that we can train modules. And this can scale because basically I'm using BPT processes to do this with all documentation of OutSystems 11. I haven't tried this already with ODC, but so basically I uploaded all 1,500 documents of OutSystems, and I asked him to generate, and it took more or less 10 hours. And after those 10 hours, I was able to get these 77,000 questions. So this was the module, or this was the results that I used to train this module. So the results you see here, these ones, are after the training of this process. Of course, this could be improved a bit because I used all the data to train, and I didn't. In theory, when we are performing fine-tunes, we should always have a set of data to train and a set of data to evaluate, and I didn't do that, but it was more to see if it was possible to generate. So that's it. I wanted to show a bit here this application. It's a very simple application, but feel free to give me ideas if you guys would like to see something here improved or made it different. So I really want to focus in the part of generating the files for fine-tuning. The funny thing is that after creating this application, I had a colleague in my company that asked if it was possible to create a sort of a quiz generator using AI. So they wanted to create courses for the consultants, and they wanted those courses to have quizzes to evaluate. And he asked me if there was a way to using GenAI to accelerate this. And the first thing that came into my mind is that basically if I use the same process here, instead of saying that is JSONL, if we say that these are questions for a quiz, we can have here a quiz generator, right? But to be honest, it was not the first thought that I had when creating this. Going a bit into the application, I will not deep dive of it, but an important thing here is that, and I do believe that this is a very good approach when interacting with GenAI inside OutSystems and inside the processes, is that we can use BPTs, because BPTs, they are very good to follow, basically breaking complex tasks into smaller tasks with a flow, with a proper flow. And basically in a very fast way to explain this, what basically I'm doing is that I'm creating processes that instead of having human activities, I replace them by GenAI activities, because GenAI can replace better human tasks than machine tasks. For the machine tasks, we already use OutSystems. So you guys can see here that I have this four processes, and yeah, this one is basically to convert the documents to Markdown. So it's called the Microsoft AI Intelligence Service. So it's not a big deal here. But then I have here the process. This one is to generate the big JSONL files, because due to the fact that they are big, I don't want the user to wait for the 77,000 questions to be converted into a file. So I create a process for that. But these two are the ones responsible for the process. So in here, this is where I start the process. I basically clean the previous one, and then I process the document. And what I do in a very fast way is that I break the file content into sections, right? So you guys can see here the logic, big logic to break into paragraphs. But after breaking into those paragraphs, you guys can see here that I create a section, and by creating this section, it triggers then the BPT for that specific section. And so inside of this section, what basically I do here is I call the GenAI model to ask him to generate the messages. So you guys can see here, I create the thread there, I start the run, I wait, check if it's done. If not, wait again, check if it's done, and when it's done, I get the message, and then I convert it back to JSONs, and I save the questions based on that. So the moment that you guys start having these processes more automatized, or basically you start using this, it becomes really easy to put GenAI activities in the middle of processes, right? I have a lot of projects nowadays where I simply replace GenAI tasks calls in smaller processes to allow to use GenAI in the middle of the applications. Of course, that with ODC this becomes easier. In this case, this application I did it in O11, but I'm already start using ODC, because ODC has also the AI agent builder, and the AI agent builder exposes two service actions. That is basically the call agent, where you can simply drag that service, and he does all this part inside of that action. So it becomes easier on that way. So yeah, this is basically how the application works. Again, feel free to share thoughts, give ideas, let me know what you guys think. And this is basically the first video of a series of projects and ideas I had with time. I will share the videos that it comes here, and thanks a lot. See you guys.